Hello and welcome to Autumn Math. In this edition of Autumn Math, we're going to apply the remainder and factor theorems in doing polynomial long division and synthetic division. Before we get started with the long division and synthetic division process, let's define some terms. Alright, polynomial long division terms. So we all want to be on the same page, and as I explain what we're doing, you need to know these terms so you can follow along. Right, the divisor is the value by which you divide the dividend. So here I have my long division set up. 2x plus 3 is my divisor. In my box here, my half box, I have the dividend, the value by which I'm dividing the divisor into. I have the quotient, which is the balance that I get after I divide the dividend by the divisor. And the remainder is the remaining value of the product of the quotient and the divisor that makes up for the difference between the product of the quotient and divisor and the dividend. So one more time, the divisor is the value by which you divide the dividend. The quotient is the resultant value determined by dividing the polynomial by the divisor. So the quotient is what we get on top of that box. It's a resultant value after we do the dividing process. The remainder is a fraction of the divisor, which is less than the divisor. It does not wholly divide into the polynomial or the divisor. Okay, let's get started with some long division. Alright, polynomial long division steps. First, we're going to write the dividend of the polynomial and the divisor in long division form, which means we create this half box here. I have x squared minus 2, which is my divisor, x cubed plus 3x squared plus 0x, and I'll explain why I'm putting 0x there in a second, minus 7 as my dividend underneath the box. Now, when I have a polynomial or a dividend that does not have a given term with a given exponent, then I'm going to put a placeholder there, and that placeholder is going to be 0 times the variable to whatever power that is that I'm missing. So I start with x to the third. That's my largest degree exponent for any given term in the dividend. I express in standard form the polynomial from the highest degree exponent to the next highest degree to the next highest degree, so on and so forth until I get to my constant. So I express it in that order. There may be some spaces in the expression that don't have a coefficient or a value for a given exponent value. So in this case, I don't have a coefficient or a value for x to the 1. So as a placeholder, I'm going to put in 0x, and I call these absent terms, but we need to account for them as part of a long division by putting in these placeholders. Okay, so I write my dividend and divisor in long division form. If the polynomial does not have a term of a given degree, then I'm going to add a placeholder for that given absent term, which I've done. Now, step number 2 is I'm going to divide the term with the highest degree in what is left of the polynomial or the dividend by the first term of the divisor. So I divide, in this case I have my first term, it's the highest term left because we haven't done anything yet, by x squared, and I get x. Okay, I multiply then x times x squared and minus 2, and my result is going to be x times x squared is x to the third, x times minus 2 is minus 2. Then I'm going to subtract these values from that I got the product of the quotient and the divisor from the dividend. So x cubed minus x cubed gives me 0. 3x squared minus 0 gives me 3x squared. 0x minus 2x gives me plus 2x. Minus 7 minus 0 is equal to negative 7. Now I have the balance here of 3x squared plus 3x squared plus 2x minus 7. The value with the highest degree is going to be 3x squared. I divide x squared into 3x squared, and I get plus 3. So I'm going to add plus 3 to my quotient. And I multiply that plus 3 times every term in the divisor. So now I have 3x squared minus 6. And I subtract 3x squared minus 6 from the balance here. And my difference is going to be 2x minus 1, and that's going to be my remainder. So my quotient is going to end up being x plus 3. My divisor was x squared minus 2. And my remainder is going to be 2x minus 1. And we'll talk about remainders in just a second. Right, so we subtracted the product of the quotient and the divisor from the polynomial or the dividend. And we continue this process as we did until the remaining difference between the product of the divisor and the quotient has a power. So the difference, this difference here, has a power and a coefficient that is less than the power and coefficient of the divisor. Right, so once that remainder has a coefficient and a power that's less than the power and coefficient of the divisor, then we have our remainder. So again, x plus 3, remainder 2x minus 1 over the divisor x squared minus 2. Okay, let's talk about synthetic division. So we're going to use synthetic division when the divisor is in the form x minus k. What does that mean? Well, I have here my divisor x minus 3. When the divisor is in that form, I'm going to change my divisor for synthetic division to be 3. So if I have x minus 3, my divisor is 3. If I have x plus 3, my divisor becomes negative 3 for just synthetic division. So I can say identify the divisor as a first step. In synthetic division, the divisor of x minus f is f. The divisor of x plus f is going to be negative f. Okay, next step. I'm going to create a synthetic division system. I draw my half box. Here it's a long L. I place the divisor, which is 3, in the upper left corner outside the L. In the same row as the divisor, I write the coefficients of the polynomial. So I had plus 2, 9, 14, and 5, and I wrote those in the first row. And as with long division, if there is an absent term, I'm going to write 0 as the coefficient in its place. So for example, if I did not have the term 9x squared, I had just 2x cubed plus 14x plus 5, I'd still need to keep a placeholder for this value, and I'm just going to write the 0 in here to represent the new polynomial that I just created. Alright, so remember that placeholder for both long division and for synthetic division. I'm going to take this back out and continue with what we started. So I have my divisor in place outside the L, my coefficients of the dividend or the polynomial inside the L in the first row. All right, so I have my divisor 3 or x minus 3, my dividend 2, 9, 14, and 5. I'm going to go through the process here. In the first column, third row, I'm going to place the value of the first coefficient of the divided polynomial, or the dividend. So what does that mean? I'm just going to take this 2, I'm going to drop it down. It's going to be below the box in the third row. Then I'm going to multiply 3 times 2, that gives me 6. Then I take the sum of the coefficient of the dividend, and I add it to this product of the divisor and the quotient. It gives me 6. 9 times 6, or 9 plus 6 is 15. I multiply 3 times 15. I get 45. Add 45 to 14. 59. 3 times 59. I get 177. I add 5 to 177. 182 is my remainder. Okay. So my resultant value is going to be, I have my divisor of x minus 3, and it's going to be multiplied by 2x squared plus 15x plus 59, and that's going to have a remainder of 182 over x minus 3. Okay, so again, I add the value in the second row, product of the remainder and the divisor, the value in the first row, coefficient of the polynomial or the dividend. I write the sum in the third row and in the same column. I repeat these steps 4 and 5 until I've added the last product of the divisor, remainder of the last coefficient. Okay, the final value in the third row is your remainder. I express that value as a fraction over the divisor, what we use as divisor in long division. And I fully express the resultant factor of the division process. So here, let's go through the process again. My divisor x minus 3 becomes 3 in the synthetic division system. I drop the 2 down. I multiply 3 times 2. I take the product of 6. I add it to the second coefficient, or the coefficient of the second term. I have 15. Multiply 3 times 15 to get 45. 45 plus 14 to get 59. 3 times 59 to get 177. 5 plus 177 to get 182. My finished product is x minus 3 as my divisor, 2x squared plus 15x plus 59 as my quotient with a remainder of 182 over x minus 3.